Hi everyone, this is Edwin from the Axelar team, and in this video I'm going to show you an example of how Axelar can be used to add blockchain interoperability to an already existing lending platform like Compound Protocol. The code for this example can be found at our GitHub repository, Axelar local GMP examples, where you can find this one and many other different examples. Let's first talk a little bit about the architecture of our example code. And we are going to use what's called a home base and satellite architecture, where basically we have a home base chain, which is going to be our home for our main logic and state of our application. Then we are going to have different satellite chains where we are going to deploy a very simple smart contract whose primary purpose is just sending and receiving calls. But all the logic and state of the application is going to live on a single chain, which is the home base. Since our home base contract is going to interact with the Compound protocol, we need to take note of some of the already deployed contracts that Compound provides. For example, here it's important to notice the controller, which is the main contract from the protocol. And here are a bunch of C tokens, which basically represents all the assets that the protocol supports. So for our simple example, we are just going to pick two of those. One to supply collateral and the other one to borrow the asset. So for our case, we are going to use WBTC to supply as collateral, and we are going to borrow sushi tokens. Before jumping into the code, let's talk a little bit about the workflow of our example application. We are going to implement two functions. One, supply and borrow, that will supply some collateral and then borrow from another different asset. And the next one is the repay and redeem, to repay the loan and redeem the supply asset that we provided first. For the supply and borrow, we are just calling the satellite contract. This contract is living on the satellite chain and it's deployed by us. And the main function for this contract is just to redirect the call to the home base contract in the home base chain using the Axelar network. The home base contract is the one that is going to be interacting with the Compound protocol. So after it receives the supply and borrow call, it will call two functions on the Compound, one mint and one borrow, and they are being called to each of these C token contracts. One for the token that we are going to supply, and the other one for the token that we are going to borrow. So the mint calls the WBTC C token contract, and what we are doing here is we are transferring the asset and supply it as collateral in the C token contract, and in return, the WBTC C token contract will give us some C WBTC tokens. These C tokens are used by Compound protocol to keep track of the supply collateral and the liquidity that any account has, and they can later on be redeemed back to the WBTC tokens, and together with whatever amount of tokens have been accrued because of the interest. So the second contract is borrow. So since we already provide some collateral to the Compound protocol, we can call this borrow to a different asset to get a loan. So we do this to the sushi C token contract, and in return, the contract will give us some of the sushi tokens that were previously locked by other users or on the Compound protocol. After we get the sushi tokens in our home base contract, this contract will use Axelar network to send those tokens across different chains to the satellite chain and directly to our user account. Once the user is ready to repay the loan, they can call the repay and redeem function, which works very similar to the other function here. Basically, it calls the satellite contract, which just redirects the call to the home-based contract on the home-based chain using the Axelar network. And what we are doing here is also transferring the sushi tokens that we previously borrowed, and we do the repayment by calling the repay function on the sushi C token contract on the compound protocol. And after we do the repay, we can redeem the CWBTC tokens that we previously got when we supplied the collateral. We can redeem them back for the WBTC tokens by calling redeem on the C token WBTC smart contract on the compound protocol. And after we get the tokens, the home-based contract can send them directly to the user account on the satellite chain using the Axelar network. Now let's jump into the code. Let's first take a look at the lending satellite contract, which is the contract that the user is going to interact directly with. As you can see, it's a very simple smart contract, only two functions. They work very similar to each other. There are just some different variables in here that we need to specify, and the tokens change, but basically they do the same thing to redirect the call to the home-based contract on the home-based chain. And this actually can be combined, but here are separated just for clarification. And so to do this, we first need to define some variables on the constructor. We specify the Axelar gateway, which is the contract that is going to handle all the cross-chain calls. We specify the name of the chain that's going to be our home base. Then we specify the address of the contract that is going to be called on the home base chain. So the supply and borrow function, what it does is going to transfer the WBTC tokens. I mean, this can actually work for whatever token, but for our example, we are going to use WBTC tokens. So we are going to transfer those to the smart contract. But since the gateway is the contract that is going to be sending the tokens to the other chain, we need to give the gateway permission to move these tokens around. So we call the approve function on the supply token contract. When we make a call to another chain, we need to provide a payload, which basically contains all the parameters that we are going to use on the receiving smart contract. For this, we need to specify which function we are going to call in there. And we do this because we can call different functions, and we need to specify the name for it. So in this case, we specify supply and borrow, and also the parameters that this function is going to need. In this case, we provided the symbol of the token that we are going to borrow, the amount of tokens to borrow, and also the user account that is calling this function. So basically, it's the user account that is going to be receiving the borrow amount. Okay, after we encoded the payload, then we can call the gateway. We call the call contract with token function in here, and we specify the destination chain, the destination smart contract that's going to receive the call, the payload with all the parameters. And since we are also transferring some tokens from one chain to the other, we also need to specify the symbol of the token that we are transferring. In this case, is the supply token symbol, and also the amount of tokens that we are going to transfer. For the repay and redeem function, this is working exactly the same, but in our specific example, since we provided WBTC as collateral and we are borrowing sushi tokens, in this case, we are repaying the sushi tokens that we borrow, and we are redeeming two WBTC tokens. Of course, this function can work with any tokens, but once we run our example, we are going to use those tokens that we pick. So the process is the same. We are transferring sushi tokens, and then we are going to encode the parameters, but this time using the repay and redeem function name. And finally, we use the gateway to redirect this call to the other chain, specifying the base chain, the base contract, the payload, the token that we are transferring from one chain to the other, which is the repay token, and also the amount of tokens that we are going to transfer. So now let's take a look at the compound interface smart contract. This is the smart contract that's going to be deployed to the home base chain, and it's going to be living alongside the compound protocol. So we use this contract to act as an interface to the compound protocol. So in the constructor here, we first receive the gateway, which is the Axelar network contract that is going to handle all the cross-chain calls. We also get the controller contract, which is the compound contract that handles most of the main functionality in there. We also provide an array of the supported tokens by this application. And we also need to provide the equivalent seed tokens that are supported by the compound protocol. So for each of the supported tokens that we provide, there has to be a seed token in the compound protocol. The first array is a string array of the token symbols, and the second one is the address of the compound protocol contracts. Basically, we create a mapping that maps the token symbol to the smart contract in the compound protocol. This line here is really important. This one specifies the controller in the compound protocol that we are entering the markets on all these tokens. We need to do this because this is the way we indicate the protocol that we could provide at some point collateral and liquidity from any of these tokens. If we don't specify it in here, doesn't matter if we supply tokens, if we transfer these tokens to the markets, they are not going to be considered as liquidity for whenever we are asking for to borrow some different token. So let's go a little bit down to the execute with token function in here. This function is the one that's going to be called by the Axelar network. So this is the single entry point when we are executing a cross-chain call from a different chain. And what this function receives as a parameter is the source chain calling this contract. And also we specify the source address of the contract that called this function. We receive the payload. Also, since this is a execute with token, we are transferring tokens from one chain to this one. We receive the token symbol of the token that was transferred and the amount of tokens. So first thing that we need to do is to decode the payload. This payload is exactly the same one we encoded here, which specify the function that we want to call and the parameters. So this is why we decoded into the function name and then the parameters that we are going to use later on. So with the function name, what we do is to select the selector of the function that we want to execute. Since there are two functions that we can execute on this smart contract from a different chain, we need to select which one is the correct one that's going to be executed by this cross-chain call. So then what we do is after we get the selector of this function, we need to call using the low-level call function. We are going to call the right function on this contract, and we provide the parameters that we need. In this case, we provide the source chain, the source address, the token symbol, the amount, and also the parameters that we encoded on the satellite contract. As you see here, we encoded some parameters that we are going to use on the receiving smart contract. These are the parameters that we are sending to the function that we are calling here. So first, let's take a look at the supply and borrow function. Here, the first thing that we do is to decode the parameters. We decode them into the token symbol that we want to borrow, the borrow amount, and the user address that executed this cross-chain call. As you can see here, this corresponds to the encoded parameters that we did here. And then what we are going to do is we need to first call the mint and then the borrow. Each one of those is going to be called on a different C token contract on the Compound protocol. So let's take a look first at the mint. What we are doing here is we are calling the mint function on the C token contract. And this C token contract, what's going to do is to transfer the tokens that we are specifying. They are transferring to the C token contract so they can be used as collateral. This is why we first need to approve the movement of these tokens. So after we provide this collateral, the main function will give us back some C tokens in return. We keep track of the new balance of the C tokens that we got, and yeah, that's it for the mint function. We supply collateral and we get C tokens back. After this, we need to execute the borrow, which is going to be executed on a different C token contract. As you remember, the first one is executed on the tokens on the C token contract that represents the asset that we are going to supply, and the borrow is being called on the C token contract that represents the token that we want to borrow. So in this case, we call the borrow, specifying the amount, and since we already provided some collateral, the C token contract will allow us to borrow some amount of tokens. Then after we get the borrow amount of tokens, we need to send them to the user that called this contract from the satellite chain. For that, we first need to give permission to the gateway to transfer those tokens, and we call send token function on the gateway. We do this to specify. We need to specify the source chain that's going to receive the tokens. Well, it's called source chain because it was the original chain that called this function, but this is basically the satellite chain. We specify also the user address that is going to receive the tokens, together with also the symbol of the token and the amount. That's it for the supply and borrow function. Then we can take a look at the repay and redeem function, which works very similar as we mentioned earlier. First, we need to decode the parameters, same with the supply and borrow. As we see on the satellite contract, we first encoded some parameters for the token that we want to redeem, the amount, and the user address, which are the variables here that we are decoding. Then we need to call two functions. Each one of those is being called to a different C token contract. The first one is the repay borrow, which similarly to mint one, this is going to transfer some tokens to the C token contract on the Compound protocol. But in this case, we are going to call the C token contract of the asset that we originally borrow. So here we first approve the C token contract to move those tokens, and we call the repay borrow specifying the amount. So after we call this, we finally repay the loan that we got from the supply and borrow function. And after we have repaid this, we can just call the redeem function in here, which will redeem back the C tokens that we got when we supply the collateral. We want to redeem them for the underlying asset of the contract. In our example, since we are going to provide WBTC tokens as collateral, we got C WBTC tokens, and when we execute the redeem, we are going to exchange those C tokens back to the WBTC tokens. So it works pretty similar. We need to just call the redeem function in here, which will provide the exchange of these tokens. After we get the tokens back, we need to give permission to the gateway to move those tokens around, and we use the send token function on the gateway to send those directly to the user address on the satellite chain. All right, that's it for the Solidity code. We now can jump into the JavaScript code, which will test this example code. This is the JavaScript code that is going to be executed to test and run our example. The entry point is this function over here, and we can notice these three lines in here that basically what these are doing is setting up the environment. The first one is setting up the home base chain. In this case, it's going to be a fork of Ethereum network. We are doing this because we want to reuse the existing Compound protocol that is already deployed in there. We don't want to deploy a whole new protocol. We are just going to interact to the existing one. So this is why we are just creating a fork of this network. The next line is setting up the satellite chain, which is just a new local network that we are going to use for testing purposes. Then we configure the Compound protocol. This is just not very relevant. We just need to do some calls with administrative privileges to allow the Compound to mint some of the tokens that were previously paused. Okay, so then what we do is we are deploying the Compound interface smart contract on the home base chain. We provide to the constructor the address of the Axelar gateway. Then we also specify the address of the controller contract from the Compound protocol. Then, if you remember, we need to specify an array of token symbols of the tokens that we are going to support in our application. And we also need to provide an array of the equivalent C token addresses to this token symbol. So for each one of those, there has to be one C token contract that is supported by the Compound protocol. For the purpose of this example, we are just using two tokens, the WBTC and the Sushi. The first one we are going to use as collateral, and the second one is the token that we are going to borrow. Next, we need to deploy our satellite contract. This time we deploy it on the satellite chain. What we provide is the address of the gateway, but this time is the address of the gateway that is living on the satellite chain, unlike the compound interface, which is using the one living on the base chain. Then we provide the name of the chain that is going to be our home base, and also we provide the address of the contract on the home base that is going to be called by the satellite. Now that we have deployed our contracts, we can start doing some transactions. First, we can use the supply and borrow that is over here. And what this is going to do is first we need to approve the movement of some tokens. These are the tokens that we are supplying as collateral. And on the supply and borrow parameters, we specify the WBTC token, which is the one that we are supplying, the amount, then the token that we want to borrow, and the corresponding amount. This part here is really interesting, is using a feature called for call. If you notice on the compound interface, we are inheriting an Axelar for callable smart contract. What this is doing is mainly two things. First, it's going to give us the possibility or it's going to enable the smart contract to be called from a different chain using the execute with token. And also it's allowing us to use this feature called for call with token. What this basically is doing is that is allowing anyone to for call any given call. So what this means is that we can skip temporarily the whole process of validation and delivery of the Axelar network. We can, if someone knows that there is going to be a call on the destination chain with all the parameters, they can call it directly without waiting for the whole Axelar network process. This will decrease significantly the finality time. But of course there is a risk involved because it's skipping the validation process. So for this risk taking, the for caller can get some or easily can get some fee in return. For the purpose of this example, this is a very simple for call. There are no fees, and it's actually not really improving any finality time here because since we are using local networks, all these networks are configured to use instant finality. So this is just being used here for demonstration purposes. And in order to call the for call with token, we need to specify all the parameters that usually are being received on the execute with token call. So yeah, so basically we need to encode the payload. We did it on the satellite contract, but this time we need to do it on the JavaScript because we need to provide the same parameters. So we encode it and we specify the source chain, the source contract that is calling the original transaction, the payload, and the tokens that are being transferred from the satellite to the home base chain. Okay, so we execute this, and then you can notice here that we are calling the relay function. This usually is not needed when we are for calling because the for caller is the one executing the transaction on the destination chain, so it doesn't need to go through the whole relay process. But if you remember, when we are executing the supply and borrow, inside the borrow function, we get some tokens back, and we need to send these tokens to the satellite chain. So when we use the supply and borrow function, we actually are doing two different cross-chain calls. The first one from the satellite to the home base, and then one from the home base to the satellite to send the tokens that we borrow. So we need to execute the relay here so that the tokens can be delivered from the home base to the satellite. After we finish this process, we can assume that the user is ready to repay the loan. So we call the repay and redeem, and this works exactly the same as the supply and borrow. We transfer some tokens, but since the tokens that we borrow were the sushi tokens, we now specify that we want to transfer sushi to the to the transaction. We specify the amount that we want to repay, and we specify also the tokens that we are redeeming. Since we got some C tokens from the previous supply operation, we are redeeming these tokens back to the original underlying asset, which is WBTC. The same one as the supply and borrow, we are for calling also this transaction. So we encode everything the same as it will be done by the lending satellite, and we provide the source chain that is executing this, the address of the satellite contract, the payload that we just encoded, and the tokens that we are transferring from the satellite to the home base chain. All right, so same way, we also need to call the relay process manually. And we do this because we are sending back WBTC tokens to the user account. So we execute this process manually. We have to do this manually because since we are on a development environment, we have to execute this, but usually on the actual live network, this is done by the relaying services. Right, so yeah, that's it for this example. Now we are just ready to test them. And for that, we can take a look at the README file that is included on the example. We can see how we can actually make a test of this. And we have to run this script by executing this command. If you're familiar with the other examples in the repository, you will notice that it's a little bit different. In this case, we are only going to need to execute this one. We don't need to execute any other scripts for deployment or creating some local networks. So, all right, let's start by executing this script, and you can see that it's first forking the Ethereum, and we will start doing a bunch of things like deploying and getting the other network set up. All right, so the script has finished, and we can see here the balance, how they have been updating through the executing of the call. We see here that we have 3 prints of these balances. The first one is just to demonstrate the initial balance of the user account. We have here some balance. Then after we execute the supply and borrow transaction, we can see how we transfer some of the WBTC tokens to the compound protocol, and in return we borrow some sushi tokens. Then when the user is ready to repay and redeem, we get back the tokens that we provided as collateral, and we repay the sushi tokens that we got as a loan. As you can see here, the balance doesn't quite match the original balances, but this is because some of these tokens are lost on fees to use the Axelar network and relaying services. All right, so yep, that's it. That's it for this example. I hope this will be helpful to you. So see you around.